what are the justification for using such a, and there are two types of variables nowadays. We can measure a construct through reflectively or formatively, so we'll be discussing about those. And then we'll see the reflective measurement model analysis, structure model analysis, mediation moderation, and we'll be doing I will be discussing some theoretical aspect as well as we'll be doing some hands-on work as well. There's a website where you can get a lot of information about the smart PLS. This is the website. So there are a lot of articles in this website. This is managed by those who are the pioneers in this PLS-SEM. So you can visit that website. There's a lot of useful information. Videos are available on this website. This is the website. There's option of resources. There are a lot of articles and stuff available. So books. These are the two books. The blue one is the 2014 edition, and the red one is 2017. So the blue one is 2014, probably is the primer on the PLS. This is the first book written by Hare et al. And later in 2017, they have a new edition as well on PLS SEM. I have these two books in soft form, so I can share later as well these two books. And they had another book in 2018 as well, which you can see the green one. This is 2018 edition. I have a hard copy, but soft copy is not available as well. So there's another book written by Ramaya et al. This is a very good book with a lot of screenshots. So this is not in soft form. You have to buy. Like I have purchased this book as well. So these are four very good books. If someone is really interested, I have two in soft form I can share. The rest two are not available. You have to purchase if you're really interested in learning those uh, PLS stuff. Right. So why we use structure acquisition modeling, right? And we will be seeing in this slide the interface of the software, what type of data this software takes to analyze, how we import the data, how we build the model. So uh, because of technology, there's a lot of advancement in software as well. So we have first generation software or techniques, and we have second generation techniques as well. Like till 80s, we have different techniques that we've been using, like cluster analysis, exploratory factor analysis, multi-dimension scaling, analysis of variance, these things, multiple regression, etc. These are the all are the first generation techniques. And when we move toward the second generation of the latest technique, we have structure equation modeling, and there are two types of SEM. One is called partial least square, yeah, or PLS SEM. Other is called covariance based structure equation modeling, or CB SEM. So there are two different techniques. They are based on different philosophical assumptions. So uh, we choose either PLS or CBSEM, but we have to justify why we are choosing a certain technique. Otherwise, you can be questions why you have chosen certain SEM. So justification should be there. In chapter 3, we do mention which technique we are choosing and why we have chosen a certain technique. So the question obviously will be asked why you have chosen situation modeling, right? So this technique has certain advantages as compared to the previous or the first generation techniques. Like if you're doing analysis in SPSS, you can model only one DV. And if you have multiple dependent variables, you cannot do analysis in SPSS. But in smart PLS, you can model multiple dependent variables, and you can run the model in one go, rather than like in SPSS. If you have multiple DVs, you have to run it like, like first time you can run one DV, and second time you have to run another DV, right? This is not the right approach. The whole model should be run in one go, but you cannot do in SPSS because those software are the uh, old ones. They don't have these options. Secondly, in SEM, we can take factor analysis and regression simultaneously. Like when we will build the model, you will see that we can do factor analysis and regression at the same time, right? We don't need to do it separately. Like in SPSS, if you have point the data in SPSS, then you have to create variables, and then you have to run regression, and you cannot run multiple DVs in SPSS. So here we can do factor analysis and regression at the same time. So this is the luxury that we have in this second generation tools. There are two types of SEM. One is called CBSEM, one is called PLS-SEM. As I was saying, that there's a philosophical difference between these two approaches, and they are based on different methodology as well. Normally, we have two types of analysis. One is called confirmatory, and other is called explanatory, right? So when we say confirmatory analysis, we are more concerned regarding testing the hypothesis or testing the existing theories. And when we use the term explanatory, we're more concerned about the latent pattern in the data where theory is less developed, and we want to see what extent these variable explain the variation within our dependent variable or target construct. So confirmation and explanation, these are two different ways of looking into phenomena, and these two also are related with different approaches as well. Like if we are doing confirmatory analysis, we will move towards CBSEM, where we are concerned with the to see to what extent our observed covariance metrics are uh, different from theoretical covariance. Means to say, we have a certain theory and we want to test that theory with the data. So we see to what extent this data fits to the model or the theory. So we are concerned with confirmation of the theory. So the approach we'll use is CBSEM. At times, this approach is criticized as well, because we will look into the model fits. When we go for the CBSEM, we mostly look into the different model fits, to what extent our model fits, our data fits to the given theoretical framework. So at times we um, delete certain items, and that's why this approach is at times called data-driven approach. So I'm talking about CBSE. The data-driven approach means that we at times we manipulate with the data. Manipulation doesn't mean that, it means that we have to delete certain items to get the uh, better model fits. So what we're doing is we are um, deleting some portion of the information uh, just to get the better model fit. So at times this is criticized as well, because the research at the end should be driven by the theory, uh, not by the data. So that's why CBSEM has been recently criticized as well, and people has shifted towards another approach which is called PLS-SEM, partial least square structure equation modeling. So we use, when we are concerned to what extent were our independent variable explain the variation within the dependent variable. So this is the explanation, right? If you are moving toward confirmatory research, you will go for CBSEM. And if you are concerned with explanation, or explanatory research, you will go for PLS-SEM. These are the justification that we use when we select this partial least structure equation modeling. Obviously, this is we see the theoretical framework from explanation or prediction point of view, right? To what extent our IVs can predict the DV? To what extent IVs can explain our DVs? So if this is the objective, we'll go for PLS-SEM. Secondly, if the model is more complex, nowadays you'll be seeing a lot of articles, a lot of um, complex model, multiple DVs, IVs, reflective, formative. So nowadays, due to this software, we can model complex theoretical framework as well. So if the model is complex, this PLS-SEM is better. And later on next slide, I'll show you what is formative way of measuring different constructs. So if you have formative construct, I think doing analysis in MOS is very difficult. Dr. Heather maybe can comment on this, how you do analysis if you have a formative construct in MOS, but in
Yeah.
PLS, doing this, PLS can handle formative
Very
construct
easily.
very easily,
Yes,
right?
very true.
And yeah, if sample size is small, at times all sample size is not recommended anyway, but at times we have certain limitations, like population is such that we cannot get a large sample size. You have a small sample, right? And you have justification of that as well. Then if you have small sample, PLS give you better result as compared to um, covariance based approach. So this is another objective or justification we can use if we have a small sample size. Um, Also, this technique is non-parametric. Non-parametric means that we don't have strict assumptions of when we do analysis in PLS-SEM, right? For MOS, like if you do go for a CBSEM, you have to have you can do analysis. I think if the data is less than sample size less than 200.
Mm.
Also, if the data is not normal or slightly away from normality, it is very difficult to do analysis
Yeah.
in covariance based SEM because that's a parametric technique.
Mm.
Uh, CBSEM have certain assumptions. If assumptions do not fulfill,
Yeah.
then the analysis in CBSEM is not possible.
Sir,
So
analysis
this
are disastrous.
disaster.
Yeah.
I have never used MO, so yeah, maybe
Yeah.
this is the right word. So
Yeah.
so this is a non-parametric technique, this PLS-SEM, and this is a soft approach. We call soft approach as well. And
Mm.
if data is slightly away from normality, PLS still will give you good results.
Yes.
Also,
True.
at some time we use latent variable scores like uh, uh, we're not doing today. We have higher order model as well in PLS-SEM. So what we do is we use these latent variable score at different stages, first stage and second stage. So we obtain the latent variable score, and then we use in the higher order models. We're not doing it today because that's an advanced level, but this is another advantage of using PLS-SEM. So if any one of you is using PLS-SEM, this type of justification you can give, and this is very much you can defend in this way. Distributional assumption, we have spoken about that. In terms of statistical power, PLS-SEM is better. These are different software that we use for covariance based and PLS-SEM, right? So a software is a tool, but the tool are used for different approaches, right? If you're using MOS, one can understand that you are doing CBSEM. That's why you're using MOS, right? If you're using SMARTPLS, we can understand that the approach or the analysis you'll be doing are partial least square structure equation modeling, right? Like M plus, all these software that you see, Lizral, M plus, they have used the approach of CBSEM and SmartPLS. On the right side, you can see the lot of other software, but SmartPLS is the very popular software which nowadays we are using. So you can see this is the chart till 2015, but you can see the trend of how PLS is getting popular in research. In fact, I think lately I was in a journal or something that it has taken over MMOs now. You can see the trend as well. From 2000 onward, there's huge increase of using this technique. This technique is used in many disciplines like organizational management, international management, HR, marketing, strategic management, hospitality, supply chain. So smart PLS is being used in many disciplines now. So moving towards the analysis in PLS-SEM. So basically it's a two-step process. When we do analysis in PLS, it's a two-step process. The first step is we call this the first step is measurement model. When we say measurement model, what it means is the relationship between construct and indicators, right? When we say indicator, and we mean from indicator is that the items you use in the questionnaire, these are the indicators. So when we're studying the relationship between indicators and construct, this is called measurement model, right? And when we study the relationship between construct, we call this is as a structure model. So PLS-SEM analysis is a combination of measurement model analysis and structure model analysis, because unless the measurement model properties are satisfied, we cannot move towards the structure analysis, because the measurement model tells us to what extent your variables are reliable and valid, right? Only then you can perform structural model analysis. Also, you can see in this diagram, uh, there's something called the measurement model, also called as outer model, and structural model is also called inner model. If you can see these slides, the outer model or measure model is clubbed, and like if you see this independent variable A and independent variable B, see, okay, these are the two variables are construct. These are these have been measured through different items, indicator one, indicator two. So the relationship between these indicators and variable A, or indicator 4, 5, 6, and variable B, this is called measurement model, or also we can call it outer model. And if you see the inner model, in inner model you have only independent variable A, variable B, and DV, right? So the relationship between the construct is structure model, and the relationship between indicators and construct is called measurement model. So first step will be measurement model, and second step will be structure model. Right. This is the interface of the software. When we open the software, this is what we see. You can see different icons like latent variable, connect, calculate. So this is the interface of the software, right? Uh, if you go in file, we can create a new project. We'll be creating as well, right? I'll be showing you. This is just to quickly show you how this software we operate, how this software.
Yeah.
So we create new project, and then yeah, when we create new project, we see. Can you see the PLS workshop a file like this, right? So when we uh, create a file, we'll see the icon like this on the left side, right? So this means that file has been created. Whatever the name we will give, the name will appear on the left side. So one more thing to be noted is, can you see the comma delimited dot CSV? SmartPLS accept the file in only in comma delimited dot CSV. So if you have a data in like SPSS, so you can go into file and save as. When you go into file and save as types, if you click on save as types, you will see comma delimited dot CSV. So you have to save your SPSS file in this format, because PLS only accept this format. Even if you have in Excel, if you have punched the data in Excel, you can go into file and save as, then you select the option comma delimited dot CSV. So this is the file that PLS will accept. We'll be doing that in. So when you have a data in uh, .csv, then if you have a interface, when you created a file, you can see the option is double click to import the data, right? So you have created a file, right? Then the next step is you have to import the data, right? So you can see clearly on the left side, there is an icon double click to import the data, right? So you have to double click, and whatever the data file and wherever it is, you can import the data file into the system. So the first step is create a data file name, right? The second step is to double click and import the data, right? We'll be doing that. So when you import the data, this is how the data automatically you will see this your item missing values. If you have any missing value, mean, median, so automatically the system, you don't need to press any option or click on any option. Just when you will import the data, the software will do these analysis, standard deviations, skewness, kurtosis automatically. So
Mm.
the next step is you can draw the model, right? And how you have to link the model, will be doing that. You can rename. You can click on the red variables. You can right click and you can rename them. You can build the model indicators. We'll be doing that in a bit,
Mm.
right? So one more thing I need to tell you, there are two ways we can measure the variables, right? Reflecting and formative. Yeah, because uh, the analysis of reflective uh, measurement model is different from formative, right? So when you're doing literature review, you have to be very careful to see how your constructs have been measured. Either they're measured previously in a reflective way or formative way. So what we mean from reflecting and formative, if you see these two mm, uh, models, we have y and x, right? So just see the arrows. In green one, which is formative, the arrows are going from items to the construct. X is construct, like maybe it's like satisfaction. If we suppose X is satisfaction, and X1, X2, and X3 are different items to measure those satisfaction, right? So if by seeing the visual picture, we know that either this variable is measured formatively or reflectively. Because if the arrows are going from indicators to the construct, it means that the construct is measured in a formative way. If the arrows are going from, if you see this y construct, if the items are, if the arrows are going from construct to the item, it means that the variable is made in a reflective way, right? So we will explain this with an example. So can you see there are two variables? One is timeliness and one is life stress, right? So timeliness is measured by three items: X1, X2, X3. X1 is accommodate last minute meeting, punctuality in meeting, speed of returning phone calls. If you observe or if you see these X1, X2, and X3, these are probably related with the same phenomena or attributes, right? Related to timeliness, this is a variable, right? You have measured it through X1, X2, X3. And if you see these three items, they are very close to each other, right? They are measuring the same attributes of timeliness. So if a variable is measured in this way, we call it reflective. Now, if you see the formative, like life stress, this is a variable. And if you see X1 is job loss, X2 is divorce, X3 is recent accident. So
Mm.
if you see these three items are totally different from each other. So if a variable is measured in this way, where every item is different from the other item, or every item is um, reflecting a different attribute of that construct. So that means the variable is made in a formative way, right? So you have to be very careful when you're doing literature review. You have to see how your constructs have been measured previously, because if you have made a mistake here, the whole of your analysis will be, will be questioned. So you have to be careful when you're choosing your construct, either is reflective firm, because their analyses are totally different. They are totally representing a different phenomena, right? If I say if it's made in a reflective way,
नहीं.
if you are making variable a reflective way, you will check reliability and validity. If you are doing in a formative way, if your construct is made in a formative way, then you cannot check reliability and validity of formative construct, right? So that's how they are different. So you have to be careful when you're choosing. Uh, so if the items are made in a reflective way, you can, because the items are very close to each other, they are making the same attributes, so you can delete the item. At times when we do analysis, we have to delete a certain, we'll see in when we do analysis why we have to delete at times a certain item, right? So
Mm.
if we're writing a construct in a reflective way, we can have a liberty to delete any item if its item loading is less than a certain threshold. But
Yes.
if you are mailing in a formative way, you cannot delete an item, because an item is representing a different attribute of those that construct, right? So
Mm.
if it's reflective, you can delete a certain item, but in a formative construct, you cannot delete an item, because if you delete item, you will be deleting a certain attribute of that construct. Then the construct will not be representing what it's supposed to represent. So in reflective, we can delete. In formative, we cannot delete. So you have to be careful. This is a paper where they have shown that how previously the model have been not built on properly, or this is we call misspecification as well. So if a variable uh, should have been measured reflectively and you have measured formatively, or should have been measured formatively and you have measured it reflectively, then that means you have misspecified the model. All your results are, doesn't make any sense, right? There was a paper, in this paper, Jarvis and McKenzie and Brodesco, they have analyzed many paper from top tier journal, and they have shown how many paper was misspecified and they were not properly measured in a reflective formative way. And these are see the names of the journal. If someone is marketing, he can see the quality of those journals: Journal of Consumer Research, Journal of Marketing, Journal of Marketing Research. These are very high impact journals. But previously, because this formative construct was not common, and also the software were not available which can treat this formative construct easily. So people at that time 10, 15 years ago, they haven't been able to do it properly. This paper has proved that many of the top tier journals, many of the articles that have been written, they were misspecified because of this reason, reflective or formative. So you have to be very careful. This is the one point I wanted to tell you.
So that was very wonderful. And before doing any analysis, we should know that whether the construct is reflective or the formative, because only then we can go by the rules. Yeah, it was wonderful.
Okay. So we know that PLS analysis is a two-step process, right? The first is measurement model evaluation, and the second is the structure model evaluation, right? So if we are measuring a construct to reflectively and we want to do the measurement model analysis, what we will check in those analyses is within this circle, right? We'll check internal consistency, we'll check indicators reliability, we will check convergent validity, we will check discriminant validity. So these four things we will check, and this is a part of measurement model evaluation, the step one, as I said, right? So unless your variable meet measurement model criteria, you cannot test your hypothesis, you cannot move towards structured model analysis. That's why I was saying that you have to be very careful. You have to take time when you collect primary data. Don't rush into the data because these software, they tell you everything, right? You cannot hide anything. Or so
True.
it's not like SPSS something where you can run regression, right? So
Very
the
easily.
measurement, yes.
Yeah.
Here you don't have that luxury. You cannot hide anything because the
Yes.
software will tell everything that what your data comprises of. Is it a good quality data, or they have the data have certain issues. So
Yeah.
you have to be very careful when you collect data. So
And
first we'll
one
check.
thing, Dr. Shahab, tell the participants as well that if they manipulate the data, it can easily be traceable.
Yeah, I'll be telling
Yeah.
though as well, because we can do all analysis manually as well,
Yes,
right?
true.
We can calculate these things manually,
Yeah.
like T value, P value, your limits, like
Everything.
VIF, everything I can calculate manually. I have done that as well. I
Yeah.
have Excel files as well. I can
Yes.
share it with you as
Yeah.
well, how we calculate manually all these things.
Yeah. That is the
So
problem
you
with
can,
us. That's why the student usually they run away from us. That we can catch them very easily.
so even if we can have certain values, we can calculate rest of them manually as well. So
Yes.
if you try to change data or you manipulate, you can easily be caught as well.
Yeah.
So
True.
make sure you collect very good data, right? The first thing we'll see is internal consistency, right? In internal consistency, we'll see three things, right? Or we have three available options to check internal consistency: Cronbach alpha, composite reliability, and Hensler rho, right? So there are three criterion available to check internal consistency. Cronj alba is very famous, but it has been criticized as well, right? You can see literature where alpha has been criticized. So nowadays, what is recommended is we should use CR, composite reliability, to measure internal consistency, right? The other two measures are the like alpha gives you probably the value on the lower side. Hensler row give you values on the higher side, right? The composite reliability give you consistency values in between both alpha and Hensel. So that's why CR is recommended, right? So that's what the latest literature says, right? Even though alpha is very famous, people do report. If you see article, you can see Cronbridge alpha. You have literature that criticize Cronbridge alpha. The next is indicator reliability. We'll see factor loadings. And for convergent validity, we see average variance expected. We also call it AVE. For discriminant validity, we have three options: Horner lacquer, cross-loading, HTMT, heterotrait monotrate ratio. The latest literature say that we should check discriminant validity through HTMT, heterotrait monotrate ratio. Horner lacquer and cross-loading have been criticized as well. There's a paper, Hensler 2015, which has proved that the first or second technique, they are not good enough to track discriminant validity. What we mean from discriminant validity is to what extent our constructs are discriminant or different from each other, because at times the constructs are very close theoretically, and if we test them empirically, they seems to be very close. So if we cannot establish discriminant validity, we have to delete one construct, right? Because if two variables are appearing similar, there's no point that you should keep both of them. That's why we check discriminant validity, that all the variable what we are building our model on different variables. So obviously we are theorizing that these variables are different. So this test tell us they are empirically different as well. If two variables appear similar, then obviously there's no justification of keeping both of them. We have to delete one variable if we are unable to establish discriminant validity. So these are the tests we'll do in measurement model. So if all the criteria, we'll see the criteria as well. What are the cutoff points for internal consistency, indicator liability? We'll be seeing those as well. So how we'll do this? For checking the measurement model, we run PLS algorithm, right? Because there are different options in PLS. So when we run algorithm, we can check the measurement model properties, right? This is how we run it, and we see different, right? So if we run the PLS algorithm, we'll come up with the interface or screen like this, right? So you can see the blue one, like final result, quality criteria. So you have different results when it's just we have clicked once, calculate, and PLS algorithm. That's it. And the system has given you so many results, right? In like few seconds. You have R scale, you have S scale, you have construct liability, discriminant. So all the results are available within a minute.
Dr. Shahab,
So,
excuse me. Yes, we have less than 1 minute. All of the participants, please join us again through the same link. Thank you.
okay.
Thank you.